Okay, we have a question about transformations. Okay, now I have a particular way of doing transformations, and if you do it this way, you will not go wrong. So step one is to look at, if you think about a cost graph, think about what new things have been put in terms of numbers. So what I want you to be telling me is that you can see a 2x here, so there's a times 2 going on, and I can see a minus 60 degrees, so there's a minus 60 going on. I'm not trying to get the order right at the moment. I'm not trying to think about the transformations. I'm just describing where the numbers have come in. And each time you have to think, is this inside or is it outside? Okay, well, inside means that we're working inside a bracket. So you can see that the 2 is not in front of the whole cos x. I can't create that 2 by putting brackets around the whole thing and a 2 outside. So this is times 2 inside. And similarly, this minus 60 is inside the brackets. It's inside the cos function. So this is a minus 60 inside. Now, in order to get the order of these things right, okay, we're going to do the ordering at the same time as we do the describing the transformations. So the fact they're inside means that these transformations are happening, they're affecting the graph in the x direction. Okay, so affecting the graph in the x direction means that if we have a stretch, it's parallel to the x-axis, and if we have a translation, then it's a vector in the x direction. When we get onto a reflection in the x direction is a bit tricky, but we haven't got a reflection here. So we just got to get these in the right order. Now, higher up this page of notes, it gives you a way of remembering this. Okay, my stupid way of remembering things is that we say that inside the house, that's where we imagine we're having a sleep, so we're lying down. Outside the house is where we imagine we are running about, and we're standing up. So because these are inside, that means they're horizontal, we're lying down. So they act in the x direction. But the other thing we remember about inside the house is that most accidents happen in the home. Don't know if that's true or not in real life, but in transformations, anything that happens inside the house has the opposite effect of what you might expect. So a times 2 inside the house is going to be a stretch, but the stretch factor isn't going to be times 2. The stretch factor is going to be times a half, the opposite. Okay, and if I've got an inside minus 60, it's going to be a translation, but it's not going to be a translation of minus 60, it's going to be a translation of plus 60. Now, the last thing we need to do is to get them in the right order. So inside the house, we're lying down, we're having a sleep. Do we stretch before we go to sleep, or do we stretch at the end of our sleep when we wake up? The answer is we stretch when we wake up. So horizontally, okay, all right, we do stretches at the end. So my 2 transformations will be, okay, the translation followed by the stretch. Okay, if I'm vertical, if I'm standing up and running about, then when I go for a run, I loosen up, I do my stretching before I go for my run. So vertically, we stretch first, but horizontally, we're lying down, we stretch when we wake up. So my translation, you've got to use the full word translation. Okay, I don't need to say in the x direction because I'm going to use my column vector to describe it. So it doesn't go in the y direction, so that's going to be a naught. It's not minus 60 because it has an accident. It's plus 60, naught. And then my stretch, I need to say what my stretch factor is. Well, instead of times 2, it has an accident. So it's a stretch factor a half. And the way we say it's horizontal is we say parallel to the x-axis. And that's how we do transformations. So the next one, what am I doing with my numbers? Well, I can see there's a 2. Now, I'm not taking away 2. This is a plus 2. So I've got a plus 2 going on. Is that inside or outside? Well, it's not inside the cos, is it? So this is a plus 2 outside. Okay. And then I've got minus cos x. Now, that may look like subtraction, but actually what I'm doing is I'm taking my cos x and I'm multiplying it by minus 1. So I'm doing a times minus 1. And is that inside or outside? Well, inside would be doing the x. Make that negative. So I'd have a minus x inside the cos. That's not happened. I've got a minus 1 times cos x. The times minus 1 is outside. So this time I've got 2 transformations both happening outside. So if I'm outside, it means I'm standing up. It means my body is vertical and I'm running around. So it's going to be 2 vertical changes. Now, I've got effectively a stretch. Okay, stretch factor negative something, that's a bit odd. And I've got a translation. Okay, well, which do I do first vertically? Well, I do my stretching before I run about. So it's the multiplication, this transformation, that's going to come first. Now, you could describe this as being, and neither of them have accidents, because I'm standing up, I'm outside the house, accidents happen in the home. So it is going to be, this is going to be the correct number for my translation. This one, okay, is going to be, I could say it's a stretch factor -1 parallel to the y-axis. Okay, that would kind of work. I'm multiplying by -1 outside. But when we multiply by a negative, something else is going on. When I multiply y coordinates by -1, then if I think about my y-axis, then 2 is going to go to -2, and -1 is going to go up to 1. So in fact what I'm doing is I'm hopping the other side of the x-axis. Okay, points are moving vertically, so our rule that outside changes move things vertically still applies, but when it's a vertical flip. What's happening is everything is turning from being that way up to being that way up, so it's reflecting in the x-axis is a way to describe it. Okay, so and remember, I do my stretch, I do my multiplication one first, so this is going to be a reflection, okay, in the x-axis. Now when I describe it that way, okay, it doesn't feel like it's a vertical change, but it is, because -1 is going up to 1 and 2 is going down to -2. I'm flipping the other side of the x-axis. Is a vertical change. But you may find it, if you really want to get y into this, we could say it's a reflection in the x-axis, we could say, or a reflection. The other name for the x-axis is the reflection in y equals 0. And you may prefer to state it that way because you can actually see the y. The y equals 0 actually matches the fact that y coordinates are mucking about, not x coordinates. So it's then, so I've got my order right. Remember, we stretch before we run about, and a reflection is a funny kind of stretch. And then it is a translation. So, when we're vertical, we stretch and then we move, we translate, and the translation is, well, it's in the y direction, so the x is 0. It's by 2 units and it does not have an accident, so it's 0 plus 2. So I've got my transformations here. And then for the third one, we're putting everything together. I can see a 3, so I've got a times 3 going on. I've got a times 2 going on. I've got a -1 going on, and I've got a +2 going on. So the first thing I do is I just decide what I'm doing with the numbers, and I decide whether it's inside or outside. Well, that 3 is in front of the cost, so that's outside. Okay, and then the times 2 is actually times 2 inside, and the -1 is inside the cost, so the cost is applying to 2x -1, so that -1 is inside. And the +2 is after the cost is over, so this is outside. Okay, and notice I've just written those down in any order, because this is for me to think about things, get that down, and then turn them into transformations. Okay, well, the ones that are multiplications, these are going to be stretches, and these additions and subtractions are going to be translations, and this one are inside, so they're going to have accidents, they're going to do the opposite. So what I'm left with is making sure that I do these 4 transformations, I think I know what they are, in the right order. Okay, now you can actually do horizontal before vertical, but there's a reason why it's a good idea if you've got a whole load of them to do vertical first. So we're always going to do vertical first, and vertically we're running about, so we do our stretching before we translate, and then horizontally we do our stretching when we wake up, so we do our translation before our stretch. So I'm going to have a vertical stretch, okay, stretch, so that's going to be vertical, means parallel to the y-axis, and then I'm going to have a translation, and my translation vertically is going to be followed by a translation horizontally, and that's why we do the vertical ones first, because in fact I can do those 2 things at once with 1 column vector that does both, and then I'm going to have my horizontal stretch at the end. Okay, so we do vertical stretch, vertical translation, which will be this number, then horizontal there, and then the horizontal translation, this number, and then horizontal stretch. Okay, so my stretch will be parallel to the x-axis. So stretch parallel to the y-axis, that was the times 3 outside. So this is a factor of, doesn't have an accident, it's outside, so 3. Okay, and then a translation. The vertical translation will be the +2 outside. So this number here will be a 2. Okay, and then I've got, because I had a +2 outside, yes. And then I've got a translation horizontally. The horizontal translation will be caused by this -1 inside, but it's had an accident because it's horizontal, it's inside the house. So it becomes +1. And then finally I've got a stretch parallel to the x-axis coming from this times 2, but it's going to have a factor, it's going to have an accident because it's inside the house, so it's going to be stretch factor 1/2. Okay, so that is my set of, well, there are 4, but 2 of them have turned into a single translation of 1, 2. And that's all those transformations. Hurrah!